So, section 12.6 is page 808. So in the last section we were solving these, and what we were really interested in was just the rational roots. But a lot of these equations gave us irrational roots as well, but if they asked us for just the rational ones, we just didn't write those. They were still solutions, they were roots, but they weren't satisfying the directions. Now they're not just going to be asking us for rational roots, they're going to ask us to solve these things all the way, and so we're going to get rational roots. We're going to get irrational roots that come from the quadratic formula. We are also going to quite often get non-real complex roots. In other words, answers that have i's in them. And the i's are also going to come from when you use the quadratic formula to finish something. So we're going to see things like this. And so here's the first of the new kinds of problems. You're going to see problems like what you did last night. You're just going to carry them all the way to the end. And like I said, you can get irrational and non-real roots as well. I'm not going to do an example of that. What I do want to do an example of is the new stuff. And so they could ask you to solve. Notice, all they say is solve, which means they want all the roots, regardless of type. 2x to the fourth minus 3x cubed plus 12x squared plus 22x minus 60 equals 0. But on this particular one, they're going to give us one of our roots. They're going to give us that one of our roots is 1 plus 3i. So this is kind of going back to the previous section, not last night's, but the one before, where they gave us a root to get us started. The difference is what exactly? What's different about the root they're giving us now? There's an I involved. There's something that happens, though, that's very nice about this, and that is this, guys. It turns out that whenever they give you a root that is irrational or non-real, so whether there's an I involved or whether there's a non-negative square root involved, they always come in pairs. So irrational and non-real roots always come in pairs. And those pairs are conjugates of one another. So that means that if x equals 1 plus 3i as a root, we're also going to get another one for free. What's the one we're going to get for free? 1 minus 3i. Do you guys understand why that is? Well, stop and think about it. Where's the I going to come from when we're solving? When you do the square root as part of what? The quadratic formula, right? When you do the square root as part of the quadratic formula, you can get i's. Well, stop and think about the quadratic formula, guys. So, for example, you might get something like negative 4 plus or minus the square root of 7. Notice you get negative 4 plus 7 and negative 4 minus 7, right? If this was negative 7, then there would be an I in here, and you'd get negative 4 plus I rad 7 and negative 4 minus I rad 7. Well, what's happening here is this guy is simplifying down to 1 plus or minus 3i. So not only do we get the 1 plus 3i, we are guaranteed that it also comes paired up with 1 minus 3i. Does that make sense to everybody? It's where it comes from. Because of that plus or minus, we are guaranteed the conjugates. So if the square root of 3 is a root, what else is a root? Negative square root of 3. Not negative 3. This only works for irrational and non-real. Right? Because 3 may have come from 1 plus or minus 2. So 1 plus 2 gives you 3, but 1 minus 2 gives you negative 1. So real answers don't come in pairs. Rational answers don't necessarily come in pairs that are conjugates. only irrational and non-real come in conjugate pairs. Okay, the other ones come in pairs, but they're not necessarily conjugates of each other. They may not be the same number at all, because we can actually simplify like terms or combine like terms. So does that make sense why this happens, guys? The fact that it happens is very useful, because that means that now I have a pair of things. Now, if x is equal to 1 plus 3i, what does that look like as a factor? Well, let me ask you this. If x is equal to just 3, what does that look like as a factor? X minus 3. If x is equal to negative 5, what does that look like as a factor? X minus 5, x plus 5, which comes from x minus the root. That's where the x plus 5 comes from. So if x equals 1 plus 3i, what is that going to look like as a factor? X minus quantity 1 plus 3i is correct. You guys see that? It's always x minus the root. Remember that problem from 2 homework assignments ago, the long division problem where we were dividing by x minus r? We had ax squared plus bx plus c divided by x minus r. That was a generic quadratic being divided by a generic linear. A generic linear always looks like x minus whatever the root is. That's what the r stood for, was a root. So if the root is 1 plus 3i, then x minus 1 plus 3i is the factor. What is the other factor from the free root that we got? What does this guy give us as a factor? X minus 1 minus 3i. Don't forget to put the little parentheses in here, guys, because what do we have to do with that negative? Distribute it. So now you distribute this. And make sure you're writing this down in your notes so that you do these correctly, because these are not hard, but if you don't remember to do it this way, you're going to be in trouble. Do you guys see that these are the two factors? Anybody with me? What you now do to do these problems is you now distribute these. So now you distribute the x into this parentheses, which gives you x squared minus x plus 3xi. You then distribute the negative 1, which gives you negative x. I like to stack the like terms. It makes combining them easier. And then we have plus 1, which doesn't match up yet, and then negative 3i. Then you distribute the negative 3i, which gives you negative 3xi plus 3i minus 9i squared. Do you guys see that? Negative 3i times positive 3i is negative 9i squared. Now let's combine like terms. Notice what happens to your regular I terms, guys. They cancel out. If you do this correctly, they will always cancel out. When you are done combining like terms, there will not be any i's left. If you have i's left over after this step, you did something wrong. The i's will work themselves out so that they disappear. So this gives us x squared minus 2x. What does this turn into? Plus 9. And 1 plus 9 is 10. So we know this is going to factor into x squared minus 2x plus 10 times something. Now, how do we go about finding that something? With what? Don't need that. Not at this stage. Okay, well, how are we going to factor it? Long division. Very good. We're going to divide that x squared minus 2x plus 10 out, right? And when we do, what's our remainder going to be? 0, because we know we found a factor. We're guaranteed that this is a factor. So what you now do, can I erase this, guys? Everybody okay with the stuff on the right? Okay. What we're now going to do once you get to this stage, now that we've built that one factor, we're going to divide it out of our polynomial. And we have to do that with long division. Why? Why can't we use synthetic? Because what? Yeah, it's not linear. That's the answer. It's not linear. It's x squared. So this is what we do, and this is why you needed long division. X squared goes 2x squared times, so that's 2x to the 4th, minus 4x cubed, plus 20x squared. Change your signs and add. Those are gone. You get x cubed minus 8x squared, and then you bring down the plus 22x. Then you do it again. This goes in plus x times. So that's x cubed minus 2x squared plus 10x. Everybody with me so far? Change the signs. Add. Those are gone. Negative 6x squared plus 12x. Bring down the minus 60. And that goes negative 6 times, which is negative 6x squared plus 12x minus 60. And notice that when we change the signs and add, what do we get for a remainder? Which we knew we'd have to get. So if you don't get a 0, you did something wrong along the way. Yes, ma'am?
When you divide, like, x squared to the 4,
Uh-huh.
squared, so it's actually supposed to put it, like, above the 12x squared?
Doesn't matter where you put it. The only time it matters, we talked about this when we first went through this lesson a couple sections ago. The only time that matters is when you're doing regular long division. Now, you certainly can put it up there. And if that helps you, you can, but there's no reason why you have to. The only reason you ever have to stack those things in particular places is when you're working with regular numbers. Right, 3 goes into 15 5 times. Subtract 0, bring down the 1. 3 doesn't go into 1, so you put a decimal point there, and so you bring a decimal point up. So it's only really when you're working with decimal points that you have to make sure you keep things lined up so that you bring your decimal point up to the right place. Does that make sense?
Yeah.
Other than that, it really isn't going to make any difference to our answer. Okay? Now, again, if it helps you keep track of what you brought down and what you haven't, that's fine. But I draw these arrows so I know what I brought down and what I haven't. So it's more of a personal preference thing rather than a necessity. Okay, good question. So, any other questions up to this point? So we now know that this other factor is going to be 2x squared plus x minus 6. Now, this doesn't factor anymore. Does this factor? Well, let's see. It would have to be 2x and x. And we would have a 2 here and a 3 here. This would be minus. This would be plus. Do you guys see that? That's going to give us 2x squared plus x minus 6. So this gives us x equals negative 2. That's a solution. This gives us x equals positive 3/2. That's a solution. What solutions did we get from this one? It doesn't factor, so what will we have to do to solve it? No, we don't. Don't we already know what it comes out to be? Remember, we made this from those two roots. We already know what those two roots are. So you don't have to reinvent the wheel, guys. Now, could you do the quadratic formula to make sure that it gives you those, to make sure you didn't do something stupid along the way? Sure, absolutely. But as long as you did everything correctly, I'm sorry, in the step that was here that I erased, you know what two solutions you're going to get from that, guaranteed, because we built it from those two solutions. Any questions about how the conjugate roots work? Now, you would do exactly the same thing, guys, if they told you that the problem was this, that x is equal to 1 plus square root of 3. Your factors would be x minus 1 plus rad 3 and x minus 1 minus rad 3. That would be the free root. And then you would distribute the negatives and FOIL, or distribute those together, and then do your long division. So you don't only do this for i's. You do this anytime you're going to have conjugate roots, which means you have irrational roots or non-real roots. Again, with rational roots, you don't have to worry about this. Questions about that? Now, remember we also had those problems, not on the last assignment, but the assignment before, where they gave you, like you had a cubic polynomial, and they gave you that negative 1 was a root with multiplicity 2, and x plus 6 was a factor. They can do the same thing now, but now they're going to tell you that the degree is equal to 3, and they tell you that one root is negative 1, and another root is 1 minus 2i. Well, how many roots is this going to have altogether? 3. They gave us 2 of them. How do we get the third one? Exactly. We get the conjugate for free. And so this would look like x minus negative 1, which is x plus 1. This will be x minus, parentheses, 1 minus 2i. And this will be x minus parentheses 1 plus 2i. And now we just have to multiply this all together in order to get our polynomial. Okay? Which of these parentheses should we multiply together first? Which one do you think? The last two. Don't always do the last two, but on this one it's the last two. Why is it the last two on this one? The ones with the i's. Multiply the ones together that contain the conjugates, because that's going to simplify your life. You don't have to do it that way, but it's going to make your life so much easier if you do, guys. Distribute the negatives, and then multiply these two together, and then when you get that answer, you distribute the x plus 1 into this parentheses. Yeah. Yeah. Questions about that? We've already seen problems like that, so I'm not going to work through the whole thing. We've seen how that works. But remember, guys, when you create your factors, it has to be x minus the root. It's not just the root. You don't just put 1 minus 2i and 1 plus 2i in parentheses and FOIL them together. It's x minus the root and x minus the root. And when you're done distributing these, should there be any i's in here? No. If there are i's left in there, then you did something wrong. Go back and recheck your work. It's a good way to catch mistakes. That's it, guys. Questions about that? So again, we're not going to talk about Descartes' rule of signs. Descartes' rule of signs helps you figure out before you do a problem how many positive roots it has or might have, how many negative roots it might have, and how many non-real roots it might have. That's what Descartes' rule of signs is used for, but we don't actually apply it to anything here, so I'm not going to worry about it this year. We're just going to deal with this part of the section. Okay. The homework assignment then is going to be assignment number 52. You give the rest of the period to work. You were going to do page 812 through 813. I think we'll keep this kind of short for you to help you guys out. Let's do... I'm making an adjustment here, guys. Let's do 1 through 6, and then we'll go 7 through 19 odd. So 1 through 6 is all, and then 7 through 19 will be odd.